G'day comrade subscribers, hope you're all well. So I'm just working on this Leningrad-2 or St. Petersburg 2 ZX Spectrum clone. So this is from early 90s, so Soviet era, so 1991. It came in quite a nice case, like so, but that's a separate video. This one's about the ongoing issue that we have here in the West of trying to add expansion connectors to these boards. So as you may know, the Soviets used 2.5mm pin pitch, not the 2.54mm or 0.1mm, 0.1 of an inch pin pitch that we use in the West. This 0.04 of a millimeter doesn't sound like much, and it's certainly okay for say 8 pins or something like that. But once you get to 20 pins, Western parts, you need to kind of arch them, you need to kind of bend them. Not good. So and obviously a similar thing happens here with the expansion connector. Yeah, it's actually connected up. So this is the Leningrad-2 here. So you can see we've got the pin out for the expansion connector. So it should, I don't know if it's exactly the same order as the Spectrum, I need to look at that. But one issue is you can't just plug a standard Spectrum peripheral in, because for a start they expect edge connectors. And it's not so simple to just add an edge connector because of the pin pitch difference. So if we have a look, so this is 2 by whatever, 2.54, and okay, even though the holes are a little small anyway, so I might have to drill those out. If you have a look, you can see that they just, so if we start on the right, we line up, but by the time we get to the left, you can see that we miss the hole. So certainly by the time we get up here, there's no chance. So it's been a kind of an issue. You can still get Soviet connectors, obviously in Russia, but there's obviously issues there, but also in Ukraine. You can get connectors if you know somebody. So what else can we do? So I had a thought of designing, thanks to PCBway, a converter. So I'm thinking of maybe like use a pin header like so. So plug it in vertically, and then have a daughter board sticking out with the standard Spectrum edge connector. So you need the converter board for a start, so you can get an edge connector, but also so that we can convert this 2.5mm pin pitch. Now obviously you can't just plug that straight in. So the idea I had was using the board that I create, is use that as a jig, and I'm going to have to individually break these up. And I don't know, we might be able to get away like that. So the idea is that I just break up, chop off each one like so, and then use this board that I'm going to design to plug all these into, and then I can hold them in place and solder them into the board. So that's the idea I've got. So let's go. That looks like it's going in. Okay, looks like it works. So the idea is just I'm going to have to go through manually and put all these in, and then using my little converter board, I can plug it on top, make sure everything lines up, solder these pin headers in, and away I go. So let's design that daughter board. Actually, before we get started, we can have a look at a traditional Sinclair edge connector just to compare. So we can see that actually we've got 32 pins. It's 32 by 32 on the Leningrad, whereas how many we got on here? Well, it goes up to 28. So we've actually got less pins. Now the reason for that is that generally they use these SNMP type connectors, which are very similar to these, is it DIN? I can never remember the name. DIN 46412 or something like that. very similar. This is a 3x32, so obviously not a 2x32, but I think, yeah, that is a DIN connector. So something like this would probably fit if I didn't have, if I didn't have 3 rows. I could actually just connect that on like that. Of course, I don't have anything that plugs into this, so that doesn't solve the problem. But yeah, so that's generally, you can actually see under here that there's a whole lot of pins that aren't actually connected, and that's just because, well, you know, it's a 32-way connector as standard, so it's only these pins here. I think starting from pin 3 to I think it's 26 or something that are actually connected. So they're the only ones that we really need to do to match up with the Sinclair Edge connector. So that is the plan. Right, we've got our ZX80 Edge connector and we've got our Leningrad Edge connector. So there are some differences. So we couldn't do anything straight through anyway. We would have to convert it. So I've started a KiCad project, Leningrad-2 expansion, or Leningrad-2. Okay, so the schematic is pretty simple, really. It's just 2 connectors connected together. So you could, if you wanted to do something really quick, you could look up a generic connector generic. Can I do that? And see, what have we got? So we've got a, is it 23? 26 minus 3 is 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 24. That's what I thought. It's not just 26 minus 3, there's one. Anyway, so we've got 24 2x24, so we could just go here and grab a 2x24, connect to 2 rows, 2x24, can I just type 2x24, 2x24. This always trips me up as well, whether it's counterclockwise or odd even, because it depends on the footprint as well. So, but we do want, I guess, see, in the Spectrum one, it's A and B. Whereas on this one, it's also A and B as well, isn't it? So here we go, letter, yeah, this is what we want, A1, B1. Yeah, letter last. So we could just do that. So one of those, and then connect them up, sort of thing. But we want to make this a bit easier and I don't know, a bit nicer, is to actually design our own symbol first. So there's a clueless engineer. So let's go and do a new symbol. It's going to be called, so, Leningrad-2 expansion, I guess, and it's going to be, well, J in the in standard, but they normally called X on the Soviet ones. And then what we do is, actually what you could do to make it easier, maybe, is just save that. Now if we go and have a look at our connectors, connector generic, if you want to save a little bit of, well, of course, depends whether or not you're actually saving time. 2x24, what did we say? This one, A1, B1. So we could just copy that, and we go back up to our one, Leningrad-2, and paste it in. Okay, like so. Can we just? I think it might be easier just to draw it from scratch. That way we can label each pin like so. Yeah, I think it might be easier just to. Let's just do it from scratch, shall we? It's just as quick. So we do this. We draw ourselves a box. Doesn't matter if it's not big enough. We can color it in. We want to color it in yellow like everything else. So we want to fill with body back. Fill with this. Let's go red, shall we? Was that going to make it hard to read? Something different. All right. Oh, don't worry. I'll change that. It's going to. Let's just go. Let's stick to standard, same as everyone else. Okay. Now we add our pins. So this is for the Leningrad. So we start off with, it's technically pin 3. Oh, we can call it pin 3, I guess. Keep the number. Yeah, well, true. It is true because there's 32 pins. We're only using 24 of them. So first pin name is A14 address, and it's pin A3. Like so. Bi-directional because it's an address bus. And we stick it there. And then continue on. So next one is clock. And that's pin A4. Clock, I assume, will just be output. I don't know if it matters too much on expansion, whether you just put everything as passive, I don't know. NMI, so NMI will be to the CPU, won't it? So, or is it, I'll say, is it active low? Should I put bar NMI? I'll do bar NMI, shall I? NMI, like so. Pin A5. That'll be input to the CPU. I don't know, I should just probably put all these as bidirectional. Right, which is active low, so I'll do active low. So I'll continue on with this, although I've skipped ahead, it should actually be IO request. You're probably just about to write a comment. Don't worry, I picked it up. IO request. Which is pin A6. Is that just to the CPU? I don't know. I'm just going to do that. Okay. Don't worry. Don't bother telling me if it's wrong or not. I'll double check it on a Z80 pinout before I finish all this. But anyway, so this is the idea. So we'll continue on. Right, that's pretty much it. Just roughly done, nice and quick. I think that everything's around the right way. Let me just save that. Yeah, I think, yeah, right. So, now what we could do, because we need to do the footprint next, that's what's going to require a bit of work. So we could just look up the, okay, that's appeared down here. So we could just, if we were doing just a normal 2.54 mil, then we could just use the generic 2x24 2.54, so it'll be vertical like so. This is where I get confused sometimes because there's one of these, but the pin numbering might be wrong. So 1, 2, 3, 4. So let's see how it's going to convert my A1, B1 to it. But we could just use this one here, but the problem is it's 2.54 mil. So what we will end up doing is copying this and then adjusting each pin. So it's just 2.5 mil off. So we won't do that yet. Let's just save that. We'll do that separately. So we'll go into here. We'll go into the footprint editor. Down here. Okay. So what we want to do is first of all, we'll go and get that pin header. I don't really need to do this, but there we go. So vertical. Could do horizontal, but in this case I want to do vertical like that. So let's copy that. And now let's create a footprint. Is it create footprint or new footprint? Probably. There is a footprint wizard. I've never used it. Available footprint generators. So shall we look at this? Touch slider, barcode, SDIP. Might be interesting. So no, it's not that. It's not create footprint. We want to do new footprint. Okay, so there we go. Now let's change the grid. Do we have a 2.5 mil grid already? We do. Now let's set the origin to pin 1. Come on, pick it up. Pick it up. Let's just make sure. Hopefully that should be there. So if we measure, it should be 2.54 at the moment. Yep, 2.54. What's the difference? Is it similar this way? Oh no, 2.5. Okay, well that's good. That already matches. So we don't need to worry about the horizontal. Right, so the way I do this one here, I might need to adjust the pad numbers, but you can see here, so we've set pin 1 as the origin. So this one's at 2.54, so let's change that to 2.5, and it's slightly moved. This one's at 5.08, so that should be at 5. You can see it's slightly moving. This one should be 7.5. So you can see how basically cumulative errors. That one should be at 10. This one should be at, was it 2.5? 12.5. And so on and so forth. That one should be at 15. This would be 17.5. So at the end of it, you can see the difference. So almost a millimetre. Is that a millimetre? Yeah, almost a millimetre. So it's not actually that much, but when you look at it zoomed in, it is quite a bit. So do we need to do the same on the other side, or can we just, will it just, oh, you know what I should have done? Instead, that's why I set the grid, you idiot. We just move them all onto the grid. Yeah, like that. Ah, that's even quicker. That's the reason why I set the grid. Rather than typing in the numbers individually. Alright, so I'll finish this off. Then I need to go hang the washing up. So I'll just get the pins all aligned, then we'll just adjust the, yeah, like that. I'm not too worried about this actually. I could just, no, I need to change the grid. So there we go. Now we have a Soviet 2.5mm 2x24 connector. So I probably could have made a 2x32 as, you know, for other things, but we'll just do it like that for now. So we want to save that. Let's just change some settings. So we'll call it the Leningrad-2 expansion bus. Same value. Leningrad-2. Component type through hole. Does it make any difference? There we go. Let's save it. So now that we've done that, if we go back to the symbol editor, we should be able to associate that. So we don't need to manually assign it every time. So if we have a look on Clueless Engineer, like so. Okay. Actually, what's the 3D? Can we have a look at the 3D model? There we go. So I probably could add text as well, no, because then the text would appear. It doesn't matter. All right, let's have a break. Let's go hang the washing up. Okay, I'm back. I just realized that I should have renamed these pins as well. Rather than just going 1, 2, 3, I should have renamed them A3, for example, to have them where I want them so that they match up with the symbol. So that'll be A3 and that'll be B3, or vice versa. I actually need to check on, I'll check on the PCB just to make sure which one's at the front, which one's at the back, because it starts from the left. So I just need to check which one's connected to A14 and which one's connected to A15 on the Z80. So yeah, basically I should do that, and then this should match up with the symbol. So this will be B4, for example, so forth and so forth. And then we'll do the ZX80 connector. So there should be a symbol already. I'm pretty sure I've got them somewhere. If not, we can find it. So there should be a symbol, and I'm pretty sure there should also be an edge connector, that footprint that someone's designed. So it's just a matter of downloading them and importing them. So we don't have to design. Of course, we can design an edge connector. That's not a problem. But if it's already done, it's already done. So I'll finish this off, double check the Leningrad, and we'll do the Spectrum. I've updated the footprint, so let's just give it a quick test. So let's stick in the new symbol, like so. So it's actually, what's it called? It's X2, X3, so it is actually X1. Okay, so that's our Leningrad. Now we've already linked a footprint, so we don't need to assign footprint. So because you can see in here that we've already got a footprint linked. So let's just update PCB from schematic, and it's appeared down here. So let me move it up to here. Okay. All right, yeah, well, haven't connected anything, so let's have a look. So we can see B3 is connected to address A15, A3 is connected to A14, which is exactly what we want, A14, A3, A15, B3. And if we have a look on the, that's kind of how we want it. So that's how it's going to plug into the Leningrad. So we've got A3 at the front, B3 at the back. I'm not, yeah, really I should change that to a circle, but for me it's fine. Okay, so that seems to be working now. We might as well keep that. We'll keep that because we're going to use that anyway. So now the edge connector for the Spectrum. So that's, we should already have, I'm pretty sure I've got it here. So there's this GitHub repository where this fellow has very kindly components has shortcuts of problems. Okay, hopefully ours is okay, but big thanks to Alvaro in Spain, mucho gracias for doing all this work and making it available. So if we have a look down here, he's got a ZX Spectrum edge connector. So I've already got that library. So let's go to, if we go to symbol editor, it's actually here, but it's actually missing. So if I import symbol, so I can't delete that. All right. Well, let's just see if we can import symbol. 313, so there should be hopefully all the symbols we need there. No, that's just bringing in that one. So let's delete that. All right, let's try this again. Import, what about if we add a library? That's what we want, global. That one there. So pretty is the footprints, and 3D is obviously the 3D. So will that work? Yes, I know it already exists, but there's nothing in it. It won't. Pin library, new symbol, save library as. How do I excise this? Discard changes. Well, that's rather frustrating, isn't it? There's nothing in it, yet it won't let me. How do I? Well, that new symbol, can I modify this library? Symbol checker. How do I? I'm going to have to edit something, aren't I? New library, add library, save library as, export symbol. Save, add library. Alright, I might have to figure out how to excise this from here. That to me seems like a bit of a bug that it's stuck. There should be some way of deleting it. How can I delete it? How can I override it? Alright, I'll have to figure this out first. Preferences. Or maybe configure paths. No, okay, no, but yeah, preferences, manage symbol libraries. That's how you do it. So where is 8 bits? There we go. So, okay, so I should just be able to relink that. So I've got it on my Dropbox, all my junk down here. All sorts of rubbish. I really need to clean this up. Okay, so that there, and then that. Hopefully that fixes it. Okay, yes, perfect. Okay, so that's what we want. So what's the two? Sorted. Okay, so that's one we want. Okay, and does it have a footprint? Doesn't have a footprint linked. So do we have to go? All right, so that's that there. Okay, so let's go to footprint editor. Okay, do I have a similar issue here? Okay, no. Perfect, there we go. ZX Con, ZX Edge. 90 degrees. Okay, so you can use pin editors. Okay. Incidentally, what's the... Oh, it's 2.54 now. All right, so it's ZX. So there we go. So let's just go back to symbol editor. I'm so glad I finally got it working. It's been bugging me for years. Okay, right, and let's go link the footprint to it that we want to use. Up here, there we go. So it is that one there. Okay. Yep. And then we'll save that. Perfect. And now we should be just pretty much right to go. Let's add in our edge connector, our new, this one here, over here. And so I could draw, see that, his looks so much better than mine. That's what I was trying to do before. I was trying to, I know probably you just need to, anyway, whatever. So I could draw lines and that, but what I've just been doing lately is just doing these global labels. So it's, for me anyway, it's a lot easier to track. You don't have to worry about accidentally connecting to. So what I do here is, you probably do, so if you start with A0, if I can just do that, and then can I just do function F or F1? There we go. So just do F1 up to A15, and then I can just drag them. Or you could do a bus as well. So you could draw a bus like so. Whoops. And then down here. And then you could connect it like that as well, actually. Yeah, okay, let's do the bus. Let's not do global labels. Let's do the bus. Actually, I just realized one other thing you could do. I wonder if you could, rather than doing it this way to make it simpler. So this is basically how the bus is. But instead of doing it this way, you could do it logically. So you have A0, A1, A2, A3, A4, and then have the correct pin numbers there. That makes it so much easier. And then you have the data bus, and then you have all the other signals. But anyway, it's not like that. So let's just, all right, let's just draw a bus down to here. Let's draw one in the middle as well. And then it's just a matter of connecting them all up. So I've probably gone way too far over here. Way too far over. Let's go there. Whoops. And then connect these up. Like so. And then we can do F1 to repeat them all, like so, and then we can do connect like that, and then again F1. So apart from it, I'll have to delete the ones that aren't connected. So the reason why I was saying have them logically A1, A2, A3 is then I can now label these A1 and do the same thing. Just press F1 just to increment it each time, but we're all over the place here. So I'm gonna have to just do it. Actually, what I could do is just do it like this. So if I go A1, like so, and then, there we go. Like that, like so. Before we forget, let's get rid of the ones that aren't connected. Like that. So yeah, it's just a matter of connecting them all up. So I'll finish this off, and then we'll start designing the PCB. Okay, I think we're pretty much done. So as you can see, there's quite a few signals not implemented, like the ROM CS signal, bus ACK. So I think we should be okay, because like ROM CS is generated by the ULA. We obviously don't have a ULA. I think we should be okay, because I'm mainly thinking of div MMC, like connecting that up or equivalent. So I don't think that's required, or bus ACK. So I think we should be okay. Doesn't work, doesn't work. But the principle of what we're doing here is, you know, is the same regardless. Yeah, so let's just tie that up. Oh, now what have I done? Ah, right. Let's do that. And let's just drag. Oh, God. Of course, there we go. All right. So let us now update PCB from schematic. Okay, update, close. Okay, there we go. So, which way do we want it to go? Let's just have a look at the, okay, so on the specky, we've got 4 pins and then the gap. So we want it like that, I guess, but which one's on top? That's B1. Is B1 on top? No, that's 14. 28A. Oh no, 1A. So 1A is on the top. So we need to... Ah, it's telling me B1. Okay. Okay, there we go. So that's... What are we looking at now? I'm getting confused. What are we... So 1A is on the left on the top of the PCB, which is this one over here, which is A15. Okay, that's right. Okay, so this has just got the pin numbering ask about face. So this should be 2A, which is A13, D7. All right, so the signals are right. They're just named differently to the picture I'm looking at here. That's cool. All right. So what we want is something kind of like that, I guess. A small little PCB. And let's just do very quickly, so it doesn't moan about, there we go, malformed PCB or whatever. So let's just do it like that quickly. Come on, something like that. Okay, let's have a quick look at the 3D viewer. So that's essentially what I want to do. So that'll plug into my Leningrad-2 with all the pin headers, and then hopefully I can just whack in a div MMC. Let's see. All right, but obviously what I need to do is I need to cut out there and obviously tidy all this up. So what I want is probably get rid of that, then I'm gonna have to draw it manually, aren't I? Let's just hide all this stuff. You don't really need all that anyway. You don't need that, let's hide that. Okay, so are we kind of in the middle? We've got 1, 2 there, we've got 1, 2. So we kind of start on the third, and here we kind of, just about, if we just move up a smidge, move away a little bit, like that. And that's what we want. Yep, so A13, that's as I drew, that's as, yep, okay. Of course, it probably need a little, let's have a little bit more space, actually, so it's sticking out a bit more. That'll help us if we need to do any vias. Right, now to draw, so edge cuts, I think probably the easiest way to do it is, what we want to do is we want to go down here, into there, and head down here, head over to here, and 90 degrees, yep, oh, no, stop, hate how it does that, stop doing that, there we go, a little smidgen up, there we go, that's where we want. 71 mil, oh, 70 mil would have been better, but anyway. There we go. So now if we have a look at our 3D viewer, now we've got our little notch cut out there. I could have, yeah, maybe I would have preferred, rather than just having a square edge there, just going from here up to there. That might have looked a bit better. Let's do it like that then. Okay, so let's go down here. Let's just take up the whole screen, shall we? There we go. That's better. All right, so let's go from here. Let's go 10 mil, and then let's go to, oh, that's some weird angle. Let's go to there, say. Hopefully I'll remember what angle it was up here. So let's go up to here, there, go over to here. Hopefully that's 10 mil still. Maybe like that. Maybe a little bit better, maybe, I don't know. Try and make some effort. And then what I like to, so I like to, what was edge cuts? Just like to round off the corners a bit so they're not so sharp. So let's just group all that. And now let's, where was it? Oh, normally I do transform. Where's the transform gone? Maybe let's ungroup that. Shape modification, there we go. Well, let's just do heel shapes. Okay, I don't think there's a problem. But shape modification, fillet lines, let's just do 1 mil. Just to take the edge off. Although I probably didn't have to do it there. So I could have, actually let's just exclude that then. Let's just select all and then deselect those 3. Now let's do shape modification. There we go. So sharp edges there. But it's just a little bit rounded on the other one, so that should be okay, shouldn't it? Let's have a look at all the layers again. Now we just start connecting them up. So 1 mil, let's just go 0.1 just to make it a bit easier. So that, why does that not want to connect? Sometimes it does this. What about, yep, well no, is that right? That was right, wasn't it? A15, yeah, A15 is on the top, okay. Where did my PCB go? There we go. Maybe a little bit like that. So that means I should be able to connect this one in a similar. Let's see. Let's go. Let's kind of go up there. Yeah, so it took a while. Obviously the trick was I had to move the ZX, well I had to move the two connectors further apart so that I could route everything. I also could, the free routing would also work. Obviously, I don't know, it's a I'm just assuming I'm going to get criticism because I've done this wrong, I've done that wrong. But then again, look at the title of the video. It's simple KiCad for simple hobbyists like me. I'm not a circuit design expert. I just want little simple things like this. So hopefully it works. I'm just thinking I could run. You can see I filled in some more ground zones by putting in vias. So I'm just thinking I could run another one from here to here, maybe. Stick another via there. I don't know if this is good practice or good design, I don't know. But all the ground zones are connected. So we've got some extra ground zone there now as well. That's all connected up. I can't really put anything there. Yeah. Right, so what I just finally need to do is add some text to it. So I like to put on, say that this is 1A, 1A, and then this is 28A or whatever. And then the signal names, just to make it a bit easier, and they're similar here. Yeah, I was thinking about the power. So I've ended up doing that, but I was thinking of just running a wire, just soldering a wire on here and then soldering a wire on there. But maybe this will work out doing it this way. So yeah, so I'm just going to document it now, and then we'll prepare the Gerbers, however you pronounce it, and upload it to PCBway. I think I'm done. So there we go. Let's have a look at the 3D, that'll be easier. So I've got all the signals written down, I've got the pin allocations there. So we're all set to go. That's kind of what I was expecting. So I don't know if it's going to actually work with anything. Who knows? Worth a try, you know. That's why I appreciate PCBway letting me do little experiments like this. So what we do now is we've got two options for PCBway. So we go up to Tools. So we can either use the PCBway plugin for KiCad. So that will generate the Gerber files, and upload them directly to the PCBway website. And then you've got the fabrication toolkit. That'll just generate the files on your computer, and then you can upload the zip files. So if we just click on that, and there we go. We've got all the files. Go back here so you can see here PCBway production and today's date. So then we've got the zip file there that we can just upload. So let me just log in to PCBway and show you how to do it. So here we are. So I've just gone to PCB Instant Quote, just upload the Gerber files, add the file. Oh, I need to clean out my downloads. There's so much junk there. So wherever I stuck it in GitHub, didn't I? What did I call it? What did I call it? Did I call it Leningrad something? What on earth did I call it? Leningrad-2 expansion. What's it under? Oh, ZX Spectrum clone. No, clone Delta mechanical keyboard. Clone projects. Okay, there we go. And PCB production. Upload. I think that was everything I needed to add. I don't think I was going to add anything else. So it would have been nice if it was 40 by 70, but anyway. So it's because it's under 100 by 100. So you can see here 5 is $5. We can actually get 10 PCBs for the same price. So 10 for $5, and I always do the global direct shipping. It's probably about 2 weeks to me here from China to Port Macquarie, and bear in mind that once it arrives in Australia in Sydney, there's an additional 2 or 3 days for it to get up to me, so it's pretty good. I think pretty much everything else is just standard. You can change the color if you want. That usually adds a couple of days, adds 3 or 4 days. So in this case, I don't know if it's going to work, so let's just do green. White silk screen. Like I said, everything else is pretty much just standard, so save to cart. And you can see all my other things I've got pending. I need to sort out my other Z88 keyboard. What else have I been up to? So it's a big order, so I'm going to do it all at once. So what have I got? So I've got Z88 keyboard. What was this one? ZX Spectrum. That was some other keyboard I was designing. I think this one here is the... Yeah, so this is using a Soviet BMK, so the Soviet ULA. So this isn't my design, but I've got a couple of spare new old stock. So I thought I'd give this a try because it's pretty small, but this is over 100 by 100, so it costs a bit extra. So I'm only getting 5 done. What else am I doing? What's this one here? New TI-994A power supply, and then this one I've just added now. So yeah, so pretty much go ahead. So it's about $10 US for 10 boards shipped to me here in Port Macquarie. So I think that's pretty good. But yeah, so PCBway support me, sponsor me. So they provide it to me for free, but they're pretty good to work with. I've absolutely no complaints. So if you do have any issues, let me know. I can have a chat to them, see if we can get it sorted out. But there we go. Always got to save it. Not sure if it'll work, but you know, the ideas hopefully are the same. So thanks for sticking around. I know this is a long one. Hopefully there's something of interest. Bye for now. All right, actually, before we go, let's just do a quick test fit. So here's the board. So I'm not sure what that resistor is. That's pulling something up or pulling something down. Not sure, but I can, I'll remove that and I can always connect it under here or something. So basically it should go like that. So it should stick up. So I'll stick all those in, stick onto there and sit out like that, so that then I can connect hopefully like a div MMC or something. Hopefully that'll work, who knows. But that looks okay, doesn't it? That should work. And pretty much matches the edge connector. So yeah, so that was the whole idea. Let's yeah, we'll see in a few weeks if if this board's working. I haven't powered it up yet. I've just made the VGA, well, the DIN to RGB, or DIN RGB to VGA converter. Just got to connect up 5 volts, and keyboard I'm working on, that's something separate anyway. And we'll see if it works. If it doesn't work, then obviously I've got to fix this. So let's see. Bye for now.